Hi friends, welcome to GMK tutorials. So, ఇప్పటివరకు ఇంకా ఎవరైనా మన ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండే సో ప్లీజ్ సబ్స్క్రైబ్ అవర్ ఛానల్ ఫర్ లేటెస్ట్ వీడియో. సో లెట్స్ మూవ్ ఆన్ టు ది అనలాగ్ ఎలక్ట్రానిక్స్ series point of view. Okay, so today we are going to discussing about the CMOS. Okay, so today we are going to discussing about the CMOS technology, so how we are going to use the CMOS for NAND gate realization, NOR gate realization, like that. So for that purpose we will discussing some of the related things for this case. Okay, so let us see generally. So MOS is nothing but a metal oxide semiconductor field effect transistor. Simply we can call it a MOS. Okay, so in this we have two types of transistor. One is nothing but nMOS transistor and second one is nothing but a pMOS transistor. nMOS transistor and pMOS transistor. So what is the meaning of nMOS? nMOS means this MOS transistor having a n channel. It is having a channel of n. So where n is represents a electron, that means the channel is existing due to the electrons. Okay, channel is existing due to the electrons. At the same time, in case of the pMOS, the channel is existing due to the p-type carriers or p-type charge carriers. Okay, so generally p-type charge carriers is nothing but holes. We can simply call as a positive charge carriers, right? So that is nothing but it can be formed due to the holes. Okay, so why it is very important means generally in case if you go for a, so this is a representation, right? So it is nothing but a source terminal, it is nothing but a drain terminal. In between the source and drain we don't have any channel initially. In case of the enhanced MOSFET, enhanced means that initially the corresponding transistor, metal oxide semiconductor transistor, does not having any kind of the channel. So channel is nothing but obviously source to drain there is a gap. If you are fill that gap with some charge carriers, that is generally called as a bridge. We can also call it a channel. So whenever the channel is established between the source and drain, there is a possibility of movement of electrons from drain to source or maybe source to drain. So there is a possibility for movement of charge carriers from source to drain or maybe drain to source. That is a very, very important point here. Okay, so for this case, so the channel is existing due to the electrons or maybe due to the electrons. This is nothing but a n-type channel. Okay, so n-type. Okay, so if you want to form a channel, obviously we needed some voltage. Why it is needed voltage means suppose if you are taking it is a gate terminal. Let it be considered this is a gate terminal. Just I don't want to go for the construction of the MOS transistor. Just I have to discuss very important points related to this one only. Okay, suppose if you want to go for, if you want to form a channel between the source and drain, obviously you need to form a electrons under the net of the gate terminal. How it is possible? So obviously if you are taking this a p-type material, suppose it is a p-type material. So in case of the p-type material, majority charge carriers are holes and minority charge carriers are electrons. So for that purpose, whenever the gate terminal is connected to the positive with respect to the source, positive with respect to the source terminal, at that time obviously what happens is that so the positive voltage attracts the electrons or maybe minority charge carriers of the p-type substrate. Therefore all electrons are accumulated between the source and drain. Therefore it forms as a channel. Okay, therefore whenever the channel is existing, obviously the electrons are moving from source to drain or maybe drain to source. That is the basic thing behind this one. So here one important thing is nothing but VTH. So VTH is nothing but threshold voltage. Okay, threshold voltage. What is the voltage? Threshold voltage means that the amount of voltage is required to establish a channel between source to drain, or the amount of voltage is required to conduct a MOS transistor, that is generally called as a threshold voltage of a MOS transistor. So whenever if you are supplying that minimum voltage, the corresponding nMOS or it may be pMOS transistor are going to be on condition. Okay, that is very important, right? So that is a very basic important thing. Okay, let us move on to the next slide. Suppose if you want to form if you want to on the nMOS transistor, suppose if you want to on nMOS transistor, the symbolic representation for nMOS transistor like this. This is a nMOS transistor, or else some point of time it is also can be represented like this also. It is also nMOS. So the pMOS transistors can be represented as with the bubble one representation. It is also can be represented as a direction like this. So this is nothing but pMOS point of view, pMOS transistors. Okay, so this is the case for nMOS. Okay, so here one important thing is nothing but either MOSFET is also having a three basic terminals like gate, source, drain. So here also gate, source, drain. So this is the basic scenario. So here one important point you have to note it here is the nMOS transistor. This nMOS is on for positive voltage. That means whenever input voltage Vi is greater than VTH, so it is in on condition. Here also same thing, input voltage is greater than VTH, so it is in on condition. So in this case, the applied voltage is a positive voltage. Therefore, so for logic 1, okay, 1 volt for logic 1, it is in on condition. It is on for logic 0. So in terms of the digital point of view, it may be 5 volts. It can be treated as a 0 volts also. So depending upon the application or maybe depending upon the analysis point of view, it may be varying. Okay. Now our interest is nothing but CMOS transistor. So I think all of you having some basic idea, right? From this discussion, you have to get some basic glance about the nMOS and pMOS transistor. So before entering into the CMOS inverter, we need to discuss some more related important point of view in case of the nMOS and pMOS transistor. Okay, let us see here. So in case of the nMOS transistor, let us see here. In case of the nMOS transistor, it is on for only logic 1. Suppose if you take logic 1, or just I will take it, it is also represented as for 1. For a 1 value, for a logic 1, for input 1, the nMOS transistor is going to be on condition. The pMOS transistor is on for logic 0. It is also very important. Suppose if you want to design an inverter, so inverter means that obviously it is simply called as a NOT gate. Okay, NOT gate. So if you are providing a 5 volts, it gives rise to 0 volts. In terms of one point of view, if you are providing a input as a 1, it produces a 0 value. 1, 0. That is a basic operation of inverter. So this basic NOT gate or basic inverter operation can be designed with the help of a nMOS. How you are going to designing a nMOS transistor acts as a inverter. That is a very important point, right? Noted here. So for this case, let us see here nMOS transistor is a representation. So this nMOS transistor can be connected to one network. So it is connected to the VDD. Okay, VDD. So this is can be treated as a ground. It can be treated as a output. Okay, just here I will supply the input voltage, right? So for this case, obviously it is a nMOS transistor. So how can I identify this one? So we don't have any bubble. At the same time, let it be considered if the arrow is in this direction, it can be treated as a nMOS transistor. Or else you know the representation for this one. No, don't worry for this one. Okay. So for this case, just I have to mention this one connection. So this is the nMOS represent. At the same time, this nMOS transistor is also having a terminals. Like I think all of you having. Suppose this is nothing but the input voltage, gate terminal, source, and drain. So this network is generally I can call as a pull-up network. Okay, simply I can call it a pull-up device. Okay, so it may the pull-up device may be a resistor or it may be any another transistor is also. Like if you want to design with the help of a pMOS, pMOS is also connected as a pull-up device. So there is some question will be in each and every portion back of your mind, sir. Why you are always preferred nMOS in a downward direction? That means with respect to ground point of view, we are taking only nMOS. Above that one, we are taking any another device. It may be a resistor, or it may be pMOS transistor, or any depletion type of a MOSFETs also. So there is a one reason is there, so that will be discussed in the later points. Okay. So here, if you want to analyze the application of this one, nMOS is act as an inverter. Suppose if you are providing a input is equal to 1 volt. Suppose our input is equal to 1 volt. So this 1 volt is sufficient to on the nMOS transistor. Therefore, it is on. Therefore, the output is equal to. So no way, there is no connection between VDD to output point of view. Though this output is equal to 0 volts only. That means the nMOS transistor acts as an inverter. That means whenever if you are applying a input voltage of input is a 1 volt to the pMOS, input is a 1 volt, sorry, it may be in terms of a 5 volts point. So suppose if you are taking it, the input is a 1 logic 1, at that time it produces a 0 volts. That is a inverter operation. Suppose if you are taking the reverse consideration, if you are taking a 0 volts, what happens is there, so for 0 voltage, okay, for 0 voltage, obviously the nMOS transistor going to be half condition. Therefore, the complete value can be represented at the output side. Therefore, that's why it is called as a 1. Okay, it is not a 1 volt, just you can take for assumption 5 volts generally. Okay, so logic 1 simply. Okay, so it is not a 0 volts for one case, so 0 is the logic 0 code. So this is generally called as a nMOS transistor is act as an inverter. Okay, that is called as a nMOS transistor act as an inverter. So this pull-up device, why it is called as a pull-up device means that suppose if you are taking at the output side one capacitor, let it be assumed that for initially the capacitor voltage may be charged to some value. So whenever the nMOS transistor is going to be on condition, this complete voltage can be discharging like this. So what is the meaning of this one means, the nMOS, just I will take one blank slide for this one, just analysis point of view. Suppose if you are taking one nMOS transistor, right? So output side you have a one capacitor. This capacitor is charged to the. So this is the output section, right? So this capacitor I will call as a CL load capacitor. So this is connected to the ground. This is the one for logic 1 case. So what happens is that initially the capacitor may be charged to the higher value. Suppose let it be considered it may be 5 volts are charged in the corresponding capacitor. Whenever the input voltage logic 1 is applied to the nMOS transistor, it is a nMOS. I think all of you are having this basic idea, nMOS transistor. Whenever if you are applying a input as a 1 at the time, this nMOS transistor is going to be on condition. Internally in the previous 2 slides before, whenever the input voltage is applied to the nMOS transistor, there is a possibility of channel is existing. So that means on means that this voltage is sufficient to establish a channel between these two. Therefore, whenever the channel is there is electron movement from source to drain or drain to source side. That is the basic internal meaning of this one. Okay, whenever the sufficient voltage is applied to the nMOS transistor, there is a channel is existing between source to drain. Therefore, it acts as a short circuit. So, therefore, it acts as a short circuit. Therefore, whatever the voltage stored in the capacitor, that is completely discharged into the 0 voltage or 0 volts or maybe 0. So that's why this nMOS transistor is also called as pull down. Okay, it's also called as a pull down network. Why? Because the output may be output is discharged to the 0 or output may be pulled down to 0. So initially the capacitor stores a 5 volts. That 5 volts can be make it as a 0 with the help of a nMOS only. So that's why the nMOS device is also called as a pull down device. So in the previous case, we will consider this one, right? So in case of the previous case, suppose if you are taking a pull-up network, right? We will consider the one pull-up network. So this pull-up network, so it is a why it is called as a pull-up network means that it is connected to the VDD. Okay, let it be like this. So it is a NMOS transistor. So gate, source, drain, just you will take the output here. Okay, this is a scenario, right? So what happens is that pull-up device means that this is always, if it is a non-condition, obviously the output makes us a higher potential, right? Suppose initially the pMOS is going to be half condition. Let it be considered. This is a when the 0 volts is applied, 0 is applied to logic 0, or maybe logic 0 is applied to the nMOS, it is going to be half state. So whenever this half circuit half condition means that it is an open circuit. Open circuit. Therefore, there is no connection. Therefore, whatever the voltage, that is completely coming like this. So the capacitor charged to the maximum voltage. Therefore, because of this network, output is raised from 0 volts to VDD. 0 to VDD. So that's why this network is generally called a pull-up network, because of its output is raised to the low value to the high value. It may be 0 or it may be VDD point of view if you are taking in terms of numerical values point of view. So that's why this is generally called as a pull-up device. That is very important, guys. Okay. So with the help of these basics, we can design a CMOS inverter, right? So CMOS inverter. Just I will stop within 2-3 minutes. Just we will design a CMOS transistor. Later we will discuss about the realization of the logic gates and all those things. Okay. Let's see here. So for this case, CMOS can be represented as it is a combination of pMOS and nMOS. Okay. So this is a combination of pMOS and nMOS transistor. It is nothing but a VDD. So here the input is applied to the both gate terminals of the device. So here I will take the output. So this is generally called as a pMOS transistor. Suppose if you are taking the direction point of view, it is nothing but a nMOS. So nMOS, it is a pMOS transistor. Okay, it is also called as a pull-up device. It is called as a pull-down network. Okay, so this is just a basic structure of a CMOS inverter. So this is nothing but a input voltage. Okay, so this is generally called as, it is also having a gate, source. So it's not actually, in case of this one, it is not a source actually, it is a drain, right? It is very important, guys. This is a source, drain terminal, gate and source. Here one important point is nothing but always, in most of the cases, it is very important, remember this point. Okay, so in case of the nMOS circuit, source is always connected to the lower potential of the network. In a nMOS, the source is connected to the lower potential of a network. In this network, one is VDD, one is nothing but a ground. So that means the lower potential is the ground. Therefore, nMOS source is connected to the lower potential in the network. That is very simply. At the same time, pMOS source is always maximum cases. We can also simply call it a maximum cases. We can also call almost in all applications maximum. We preferred pMOS source is connected to the higher potential in the network. Okay, so why it is connected? So then only it is possible. Suppose if you want to take the output in case of the CMOS point of view, these two terminals are a drain terminal. Then only it is possible to take the output from this case of the CMOS circuit. Okay, so let us here. So this is the connection. That means the upper part is generally called as pMOS and the lower part is generally called as nMOS. So the upper and the lower parts of the networks are connected, or maybe pMOS and networks are connected in the input side as well as the output side. The combination of gates are connected as the input. The combinations of a drain can be connected as output section. Okay, let us see here just a simple, we will see only just one application for this one, like how it is act as an inverter case, right? So for this case, let it be take. So let it be take one small example. Suppose if the input voltage is a logic one, what is the scenario? So you know guys, one is nothing but the nMOS transistors are going to be on condition. Suppose if you are applying the one input, at that time the pMOS transistor is going to be off. Okay. So for this nMOS transistor is going to be on condition. So internally it is on means it acts as a short circuit. That is very clear. So pMOS is off condition means that there is no connection from VDD to output side, right? Suppose if you are taking, there is a capacitor will be like this. Let it be considered. Some capacitor is there. So there is no connection for VDD to the capacitor. So therefore the capacitor does not charge us to the maximum value because we don't have any connection from supply voltage to the output side. So that's why the output in this case is equal to 0. Therefore, if you are applying an input of a 1, you will get output is equal to 0. So that's why CMOS transistor act as an inverter. Like nMOS is also act as an inverter, pMOS is also act as an inverter. So CMOS is also act as an inverter. But because CMOS is a very advantage, it is also very high speed operation in case of a CMOS. Due to the certain limitations in case of the pMOS and nMOS, we will come to the CMOS. So that is very important. So there is a later part, that is also very some separate strategy regarding pMOS limitations, nMOS limitations and all those things. Just we are interested in case of the CMOS only. For the time being, because of we are also interested for examination point of view, just I will restricted our analysis to only CMOS for this case only. Suppose let us see the second case also. In the second case, what happens is that suppose if you are applying a input is equal to 0, what happens? For a 0 input, so case number 2, for 0 input, just I will represent a different color. First case logic 1, just I will represent red. Okay, second case I will represent answer blue. So for 0 input, the pMOS transistor is going to be on condition. On means that it acts as a short circuit. There is a connection is established from VDD to capacitor. Therefore, the capacitor charges to the some VDD, that is nothing but maximum voltage. Capacitor charges to the maximum voltage. So for 0 input, nMOS transistor is going to be half condition. nMOS transistor is going to be half condition. So there is no on connection between the there is no for 0 voltage, for logic 0, nMOS transistor is going to be half. Therefore it acts as an open circuit. Okay, therefore the capacitor value does not discharge to the ground because we don't have any path to discharge the capacitor voltage. So that's why the capacitor maintains the same value. So therefore for a 0 input, the capacitor charges to the maximum voltage VD. Therefore it can be treated as a output is equal to 1. Therefore output is equal to 1. Therefore CMOS is also acts as an inverter. I hope it is very clear, I think. Okay, from my side, right? So because of the examination point of view, just I will restricted some more points related to analysis point of view. Okay, it is a very crucial time for examination point. I don't want to extend this videos to the maximum time duration. Okay. So thank you guys. Thank you for watching gmktutorials. In the later video, what is the transfer characteristics? Why nMOS is used as a pull-up device? So as nMOS is exactly past 0 voltage directly to 0, or maybe is there any degradation in case of the nMOS and pMOS point of view? So that will be discussed in the later session. Okay. So thank you guys. Thank you for supporting gmktutorials. Thank you.